Hello, in this video we're going to take a quick dive into a Django security issue that led to some information disclosure. This issue is several months old. This is December of 2015 that this was released, and patches have been available since that date. So what this bug can do is it can allow attackers to actually read values out of your settings. And what this means, and we can go look at settings here, is there's a number of settings that are very sensitive. Things like your database passwords are potentially in here. There's email passwords. You've got your secret key, which determines all sorts of different things within Django. So potentially you're compromising your sessions and stuff by letting this go unmitigated. So who am I? I'm Nick Johnson. I've been using Django for almost a decade now, and I've designed and deployed production systems in healthcare, finance, and tech. So let's go ahead and move on, and we'll start diving into this exploit here. So the Django project released a security announcement on November 24th of 2015, and basically they said that if you had a user-defined date format passed into the date template filter, which means that like you have a date here sometime and you want to format it for display. Well, in certain scenarios, you might want a user to be able to specify that format. Say you're white labeling your website, or you run a forum and people have different locales and they want to see month, day, year versus day, month, year, or year, month, day, whatever it is. So there's certainly plausible cases where you would have user-defined dates, and that's why I thought it would be interesting to take a look at this. So let's go ahead and see what Django changed, and then we can kind of talk for a second about why they might have wanted to do this in the first place. So if we go here, it says that the underlying function is this get format function in Django utils formats. So I've already pulled that up here, and here's the old version. So we can say get format, and it's right down here. So if we're looking at this code here, we know that there's a place where it can return settings. We can see right here that there's a getAttr call where format type is retrieved from settings as an attribute with presumably no serialization. No validation. That's the exploit here, right? So if we look, format type gets passed in. It gets passed to forString, but forString does not check and validate for, if you pass in the string secret key on all uppercase, that's certainly going to come out this function as secret key still, and then it gets returned right here as the format to be used. So if we look at the change they made, we can go down to get format again. You can see that they've added this couple of lines up here that actually do this check I was just mentioning. So if format type is not in format settings, then we can just go ahead and return it. And format settings you'll see is, time format, date format, all of these kind of values that are defined here. So why might Django, here's date format. Why might Django want to be reading settings? Well, in this case it was because they had a globally defined date format used by a number of internal functions as well. And they wanted to give users the ability to override this for all of their stuff. Unfortunately, they also gave people the ability to leak secrets. So that's enough about the overview. Now let's see a little bit of a demo. So I have set up an environment here, which I'll go into in another video, how good best practices for doing all this stuff. But effectively what we've done is we have a little Django app running, and I can just show you here. It's very simple. There's a URL, there's a view. The view is just pulling in all of the time formats and passing in now. And so what this does is we have a simple model in our database here that just stores a string of characters, and it's these formats like this. So if we wanted to do year 3 times, for example, we can throw it in here, and now we see here's the current year 3 times in a row. And so a demonstration of the exploit would be something like secret key. And you can imagine this is your user settings or something on your forum, and this is per user, so it's potentially even more difficult to find that this is occurring. But you put in secret key, and now we can see, we're getting back quite a lot of stuff here. We see some bits of dates, we see different bits of strings, but it's clear that some of the actual secret key is being returned. And what I want to say is that if we knew what all the possible substitutions are, we could probably work backwards and find what the actual secret key is. So if we come down here to our list, I'm just going to go ahead and also print out the full ISO formatted date, ISO 8601. And so every time this page gets generated, you'll see the strings are changing, but now we have our known good representation of everything. Yeah, so now let's look at how we might actually exploit this. So I've written a little script here that actually does what we're looking to do to a large degree. I've left some little bits of cleanup as an exercise to the reader, but effectively what we can do is parse this date string into a Python date. We'll use Django's date formatting and actually just enumerate all of the possible values that this date can be formatted into. And then from this raw string, we'll work backwards and we'll just start filling them in, larger to smaller. And in my case, I actually know the secret key because we've created it, and so we can go pull it up real quick here and make sure that this matches. But what I want to do is print at the bottom, so we can watch this happen here now. And we can see it didn't quite match, but it recovered the vast majority of the string. So here's the mappings, something like this. You can see that our longest string is our full representation, and then there's a number of other strings in between. And there's also some aspect of timing to this where the more diverse, or the less overlap there is between all of the different values, the easier the recovery will be. And you can also use other priors to help recover, like in the case of, say, databases. You know that this string here actually is going to have some characters in specific places. And if we wanted to, let's just go ahead and check this out. Let's make sure that this string is properly escaped, and then we'll grab our correct time again. And let's run it again and see. So you can see here, we're getting back some stuff like default, just fine. Host, you can see that the E and the T didn't quite work out. And if we go back and look, and this one will be relatively long, you can actually find in here where that E to T happened. And when you get down to these single characters, you know, it's a little trickier to recover the full values in the raw, but it limits your set of values, so you need to check very drastically. So now that we've seen kind of problems with this, you know, usernames and passwords coming through, and if we were to do this a number of times and then compare all of the output strings with different date formats, we would certainly narrow down into the correct value very quickly. So what kind of stuff can we do to mitigate this? So obviously Django released a patch, and we can just patch and take their fixes. That's preferable, and in the long run, you do want to be on the Django mainline as much as possible. Another thing we could have done, and this is security best practice here, is validate our users' choices. maybe it's not necessary for us to just allow them totally free text entry, but we could have given them a list of choices and then validated them even at the database level to make sure that nothing was getting saved in that was unintentional. Um, there's other steps you could take, but effectively what we want to do is just limit our attack surface. Any place you have free plain text entry, and we're gonna let people do whatever they want, then it's a lot more for your code to handle, and there's a lot higher likelihood of you making a mistake when you're building something generic. Generally, this is where I would show you on both the attacking, which is this red side here, and on the defending side, what it looks like when the attack is underway and that sort of thing, how you can detect it. In this case, we really don't get anything that's going to look overly nefarious. I mean, if somebody is passing in the phrase secret key, that's probably suspicious, especially in a date format. So it is possible we could go in and look these up based on your profile models, something like that. But basically, so now that we know, yeah, and let's just go ahead and do that. So here we can see that, like, some of these are the ones we've put in. You could certainly write a script to check for this kind of stuff and see if you've been exploited, but it's always possible that somebody went in, exploited you, and then changed their settings back. So it's really not sufficient to just look. Whenever an exploit like this occurs, and it's difficult to detect if you have or haven't been affected, it's generally a good practice to just go ahead and remediate as if you were, and make sure that you aren't losing any of that sensitive data. So first step to remediation is kind of figuring out if you have been attacked or not. In this case, it's going to be very difficult to tell unless you're just logging all of your traffic, all of your post data, etc. You might be able to go back to like point-in-time database of your backups of your database or something like that to see what's happening here. Effectively, you need to assume that all of your credentials from your settings file have been compromised. So your secret key can do a number of things. It can, it's involved in password hashing. It's involved in validating your sessions haven't been tampered with. It helps generate CSRF tokens. There's a number of places the secret key is used. Fortunately, it's actually relatively difficult to exploit using just the secret key. You generally need some more information, like in the case of a password reset, you need to know a current password as well. Or, yeah, anyways, there's other places, but the secret key isn't as dangerous as you would imagine it to be. That said, you still need to cycle it. So you should go and, use your password generator, use whatever it is that you've used to generate this key in the first place, and make sure you replace it. And after you've done that, it's a good idea to go ahead and invalidate all of your sessions as well. I believe Django has a command for this. Clear sessions, there it is. Right, and so it's a good idea, just let's make sure we've wiped everything out. If you have, database information, you're going to have to cycle all this stuff, username, password, and ultimately, your database shouldn't be accessible to the public internet anyways, but it's possible that somebody is pivoting through another piece of your infrastructure. So it's a good idea to just cycle these as a best practice. SMTP settings, again, if you have email server information in here, you're going to want to swap all that stuff. So realistically, swapping your credentials, seeing if, did somebody pivot through these credentials into your other infrastructure, you need to take a closer look at your email server, at your database, and see if you've had any suspicious connections. Because it's possible that you're now dealing with a much broader issue. But if you can't find any confirming evidence that you have been attacked more broadly, or even been attacked at all, then I would say that it's probably a reasonable trade-off to make to just cycle all of your keys and credentials here, patch and update, and continue monitoring, but I wouldn't lose sleep over it. So I think that about covers it. Feel free to get in touch with me with any feedback, questions, concerns. You can find me at sharktopus.com. Thanks so much.